Okay, in this video I'm going to show you the practical for the PAG 8.1, which is investigating electrochemical cells. So in this practical we're going to investigate what happens when we have a copper sulfate and copper half cell, and we're going to compare that to different ratios of iron 2+ and iron 3+. Okay, so both of those are in the solution. To do that, we're going to have our high resistance voltmeter, and we've got copper that's going to form one electrode, and because we've got two ions of iron in solution, we need to have an inert copper electrode to go in the iron solution. The other key ingredient is our salt bridge. So this filter paper has been soaking in potassium nitrate, and remember that needs to connect together the two electrolyte solutions. Okay, so we're going to start off with beaker A, this one here. Okay, so we will look at the concentrations and the ratio of the two different ions in this solution when we come to analyse the results, but let's just go through how we set it up. So the first thing we need to do is take a strip of our salt bridge and connect that to our two solutions. And remember, the salt bridge is very important because it helps the cells maintain neutrality. So it replaces the ions that are lost in the process of the electrochemical cell. Next, we need our voltmeter, and we need to make sure we put the copper electrode in the copper solution and the carbon electrode in the iron solution. So we turn on the electrode, make sure that's reading 0, and then place our two electrodes into the two separate electrolyte solutions, and we can see here that gives us a reading of 0.42. So we can then record that in our results table and move on to the next one. Now, the important things we need to remember when we're doing this is each time we measure the voltage, we need to use a fresh salt bridge each time. Okay, so that's the first one done. Now we can reuse the same copper sulfate half cell, but we're using different concentrations of our two iron ions. So again, we put the salt bridge in, and it's useful to wipe down your electrodes after each use as well. So I'm just going to go and get a paper towel and wipe those down. So I've wiped down my two electrodes, and that's important to avoid any cross-contamination. So we're now going to look at the next set of half cells. And so that gives us an Ecell value of 0.41. Again, we take those out. We get a fresh salt bridge each time. We wipe down our electrodes. And then we can move on to the third concentration. We put the salt bridge in, and we put our electrodes in. And then we can read off what's on the voltmeter. We take that out. And so when we look at these results, we'll be able to find which combination of half cells has the highest Ecell value, and then we'll look at explaining that using ideas to do with equilibrium and using ideas to do with redox. So our second to last one, we pop the electrodes in. We record our voltage. We use a fresh salt bridge each time. Again, making sure it's important to wipe down your electrodes. And we move on to our final one. Put in the salt bridge. Put in the electrodes. And record the Ecell value. Okay. So, there we have it. We've recorded the Ecell value of each of these 5 concentrations of iron 2 plus 9 3 plus solutions, and we've kept the concentration, we've kept the copper half cell exactly the same so we can get a fair comparison. Okay, so in the lesson we're going to analyse the results that I've collected and explain it in terms of redox.